We've got some tech to go through. Seems boring, I know, but having a technical understanding of what you're working with will help you make the best decisions whilst grading. Don't skip over this, don't tune it out. A lot of high-end grading revolves around getting your tech right. You need to get your settings, your setup, and your export spot on, or you just haven't delivered on your responsibilities as a colorist. We're going to do an overview of a set of attributes of footage files that we need to be aware of. Then we'll go into detail on how each one affects our approach to the grade. I make this sound like something to be considered in post, but this should be considered throughout the entire production, from pre-production right the way through to post and final delivery. We're going to cover how the codec, compression and bit depth will affect our approach to the grade. Having this down is really important, and it will also let you communicate and troubleshoot effectively with less experienced clients. Trust me, I've found that about a quarter of my time as a colorist has been spent troubleshooting for various clients who didn't know how to proceed or had no idea of the workflow of the grade. So do not skip over this module and click on through to the next lecture when you're ready. Okay, this is a good one to start with. Getting a list of codecs down can really simplify the judgments you need to make when approaching a project and what to say to your client before the grade begins. The codec is a method of compressing and decompressing video signals. That's where the term codec comes from. It's a contracted portmanteau of the terms encoder and decoder. We could go into the nitty-gritty of this, but the key things are the following. Footage is compressed and encoded with a codec, and then decoded later to be displayed on a display device. All forms of compression lose some quantity of information. The quality of the compression has a big impact on what we can do with the footage. There are a few main types of codec used in post-production. We have the acquisition codec, and these are things like AVC HD. They are used at the point of capture. We then have intermediary codecs. These are used to encode footage to be worked on in post-production, such as in the edit, VFX, and also the grade. They tend to be codecs like Apple ProRes 422HQ, ProRes 4444, DNxHD or DNxHR in varying formats, and Cineform, as well as less commonly used codecs like HUF-YUV or Apple Intermediate. We might use these because the camera's native acquisition codec is slow to decode in the edit or might not even be supported at all. They also strike a good balance between the speed of decoding and preserving the integrity of our image. After that, we have delivery codecs. These are typically quite lossy in their compression. They lose a lot of data. Because of this, we use these only once for the final step of delivery, as using them multiple times would noticeably degrade the quality of our image. These tend to be codecs like H.264, H.265 or HEVC, and IP9. Now, you're unlikely to define the entire workflow for the project you're on, so let's get down what you need to know. You want a good quality intermediate codec to work with. As I've said before, we use the good stuff in the grade. Proxy files or heavily compressed material is no good. It doesn't have the information Resolve requires for a good grade. That means ideally, we don't want to be delivered things like heavily compressed H.264 or some of the lossier intermediates like ProRes Proxy or DNxHD 36, 45 or 85, or any kind of JPEG format. Ideally, we're after at least ProRes 422HQ, but ideally ProRes or DNxHR 4444 as it preserves the most color data. Now, there are exceptions to this. If a project has been captured on an entry-level DSLR that only captures H.264, then ProRes 4444 is going to make great big files and be an inefficient use of your storage space. In that case, ProRes 422LT is usually fine, or you can use the H.264 rushes right out of the camera to avoid losing what little information there is. When delivering, keep in mind that you're probably not making the final export. You're likely delivering the graded media back to a client who will assemble the final sound mix and reinstate the titles themselves, so you definitely don't want to send them heavily compressed H.264. I typically deliver my files back in DNxHR 4444, or if I'm working on a feature, as a graded image sequence like DPX or TIFF. A simplified list of codecs for newer colorists is as follows. Use ProRes 422HQ or 4444 as an intermediary. Deliver in ProRes 4444 or 422HQ as well. If you're on Windows, then you can still accept ProRes files to work on, but you'll be delivering in either DNxHD 185 or DNxHR 4444 10-bit or 12-bit instead. You can also accept the same DNx codecs as intermediaries to work on. Now, this is a good overview for beginners. We're going to go into this in more detail later on in the course when it becomes more pertinent. Click on through to the next lecture when you're ready. This one gets a little bit heavy on the math, but there are a few simple things to take away that will make it easier to retain. We're going to talk about bit depth, and this essentially denotes the number of unique colours that can be present within an image. We have 4 main bit depths in video at the moment. We have 8-bit, 10-bit, 12-bit, and 16-bit. Now 16-bit is very rarely used and only used by the highest end equipment in productions. We typically see mostly 10 and 12-bit in the grade. The numbers in bit depth refer to the number of bits per channel, that's red, green and blue channels. Colours are represented by binary code. In 8-bit colour, we have 8 characters, so we can go from 8 zeros to 8 ones. There are 256 possible combinations of these 8 characters, which is 2 to the power of 8, and we have 3 channels. That means we have 256 to the power of 3 colours in 8-bit colour. That's a grand total of 16,777,216 colours. Now that sounds big, but in truth it's not. It's actually not very many colours to work with at all in the grade or when working in green screen in VFX. We're going to take a look at 10-bit colour to compare. A bit depth of 10 gives us 10 bits per channel. That's 10 binary characters. 2 to the power of 10 is 1024, and 1024 cubed is 1,073,741,824 possible colours in 10-bit colour depth. Do you see the difference here? Now, this is very important because higher bit depth allows us to make more accurate qualifications. Every pixel is a discrete colour, and we perceive a smooth gradient when many similar values are displayed next to each other. In 8-bit, we can actually see what we call banding. The difference between different colours is so obvious that it produces a solid and visible band across the image. In 10-bit, those bands are either much smaller or not visible at all, and this factors into our work in making secondary qualifications. I have 3 colours here, and my job is to separate the green from the yellow with a HSL qualification. I can only select full bricks here. I can't draw a line down the middle. That means I have to choose either to cast my net wide and pick up unwanted pixels, or be more conservative and miss the details that I may actually want to work on. This is not an ideal situation. Here we have more bricks showing a smoother gradient. I can now make a qualification with much more accuracy and can choose only the details I want to work with without making any sacrifices. This is much better material to work with and enables me to make more accurate and creative adjustments. This is the main takeaway here. It's better to work on higher bit depth material because it allows your secondary grades to be much more accurate. So speak to your client and check the camera they're using. If they're in pre-production and are asking about how to capture their footage, then let them know that a higher bit depth is better for the grade. Once you're ready, click on through to the next lecture. We've dealt with bit depth, now on to compression and data rate. These two things are very important as they have a direct and pronounced impact on the visible quality of the final image. We use compression to make our footage files take on a practical file size for final delivery. We can't put a feature film up to stream if it's encoded in uncompressed video and is roughly 6 terabytes. We need to strike a balance between file size and the quality of our image. In a perfect world, we'd always get 10 or 12-bit footage to work with, but we can receive heavily compressed material sometimes. It's not ideal, and I'd recommend this only as a last resort, or if the client has shot on a DSLR that's not a GH5 or Sony AS7 II. Accepting compressed 8-bit footage means that we probably won't be able to use the HSL qualifier to get very accurate results. Now, as I mentioned in the lecture on bit depth, the number of colours we have to work with has a strong impact on how accurate our secondaries can be. Take this HSL qualification on the grass, for example. It's actually very accurate indeed. A similar qualification on this heavily compressed 8-bit file looks awful. We can actually see the blocky shapes made by high levels of compression here. Now, this is a dual problem. This is a result of, yes, 8-bit footage, but also extremely high compression. It's possible to get 8-bit footage, which is a lot better than this, but it still produces these kind of jagged edges when you're keying. And this is the real practical difference that this makes. The difference between this, which is beautiful, and this, which is awful to work with. The attribute curves might fare a little better if we're gentle, but for the most part we're going to want to get the most mileage out of our primary tools and power windows when working on H.264 material or any other compressed 8-bit material. Make this clear up front and manage your client's expectations, especially if they're the type to fall in love with their Canon 5D. A lot can be done with DSLR cameras, but they undeniably have their limitations. If we work with very heavily compressed material, then we begin to see compression artifacts whilst we're working. These can manifest as blocks of colour, which can be exposed when we stretch out our contrast or when we try and pull a secondary qualification. These are unsightly and interfere with a lot of our secondary work. It's a great big block of colour and thus is very obvious when acted on by a qualification. Moving on to our final delivery, it's important to understand something called bitrate. This is a measure of how compressed our footage is at the point of export. A lower bitrate indicates more compressed footage and lower quality final image. In most cases, you'll be delivering a high quality intermediate codec, but sometimes you'll do the final export right from Resolve. In this case, you're typically going to be delivering H.264, and you can manually set the bitrate in Resolve. I find that 30 megabits per second is a good balance between file size or image quality, and in this case we'd be typing in 30,000 kilobits per second. In general, we want to use the best codecs with the least compression that our storage and workstations can accommodate. It would be great to work entirely with uncompressed video, but that's just not going to happen. It's not the slightest bit practical. So we work predominantly with ProRes and DNX codecs, as they provide an excellent balance between relatively little compression and manageable file size, as well as real-time performance in the grade. This was a decent enough intro to the notion of compression in video. We'll cover this a bit more later on as we progress into final delivery. When you're ready, click on through to the next lecture.